This is unprecedented. The new 80 class GPU isn't beating the previous generation flagship, and it's not even close. It's not like, oh, missed it by a few percent. In 4K RT Overdrive DLSS quality using the new DLSS 4 transformer model, the 4090 is 23% faster. On average of all of my tests, it's 16% faster, but if we sort for 4K rendering resolution, we get 17% faster, which is probably more accurate since we're less CPU bottlenecked at the higher resolution. In ray tracing, it's also 17% faster, and this makes me wonder whether or not the 6080 will even beat a 4090. I'm not kidding, hear me out. This is my chart of generational pricing and performance gains, and we're seeing that the 5080 delivered a 15% generational uplift versus the 4080, which is an unprecedented historic low generational gain. And the previous generations were more like delivering 49%, 63%, 39%, 51%, etc. So if the 6080 also only delivers a 15% gain, that means that the 4090 would still on average be slightly faster. I hope that doesn't happen, but look at the numbers. Now, why would this kind of thing be happening? The short answer is process node advancements, which is how the silicon the GPUs are actually produced on, are not only slowing down, but still getting better, but the better ones are getting more expensive. You're not getting the same types of new advancements at the same price or lower that like we had in previous generations. This means companies like AMD, NVIDIA, all of them basically need to ask themselves, do we deliver less performance generationally? Or do we deliver a similar amount of performance but at a higher price? Or do we eat into our own profit margins? And obviously companies aren't gonna want to eat into their own profit margins. So what we're seeing from NVIDIA here is they chose less exciting generational uplift. If they do that again with the 6080, yeah, we could be seeing a 4090 winning again. In general, new graphics cards are probably gonna be getting a lot less exciting, which is why I highly recommend, if you want the best deals, check out Jawa.gg. They have an amazing marketplace for buying and selling and upgrading between gamers. It's super convenient to make your own listings, set your own prices, and this is a great way to fund your upgrade and find great deals on your upgrade by getting it on the used market. But if you're looking for the most convenient thing ever to offload your old CPU or GPU, you can click the Get an Instant Offer button and sell directly to Jawa. You just let them know what you've got. They give you an offer. If you accept it, convenient shipping label, ship it in. Everything checks out like you said. You get paid within a couple business days. It's great. But you can also find exactly what you're looking for with their PC Finder. They have a bunch of stuff in all sorts of price ranges. They have awesome user reviews. They have a huge Discord community with over 10,000 members. And I know a lot of people are looking for that one-on-one feedback from a more experienced builder, like tell me I'm making the right choices here or improve things for me. And also I can get you $10 off your first purchase using code OWEN10. Click the link in the video description or the pinned comment. And a huge thank you for Jawa sponsoring today's video and allowing me to do massive time investments on huge side-by-sides like we are about to jump into here. Because while we know the 4090 is faster by a certain percentage, what does that actually look like in games? Because the games can vary widely, but also, is that ever enough of a difference for the 4090 to give you like a better experience that you'd really notice? And what about the new frame generation on the 5080? That type of thing. So with that in mind, let's dive into all of the details. So here we're seeing again, the 4090 is 23% faster than the 5080 at 4K RT Overdrive DLSS quality with the new transformer model, but it's only hitting 48 FPS, which means that I don't think these are the settings you would actually use. So let's go ahead and switch some things up. Another thing I want to test is the new transformer model it does take more performance to run on the tensor cores. So what about the old CNN model? Is that going to get us up to 60 FPS? And the answer is no. The 4090 is now hitting 49 FPS, the 5080 is at 39. It changes the relative performance a little bit, but it doesn't make the experience suddenly more usable. And also the CNN model looks noticeably worse, especially for ray reconstruction. So with that in mind, I think it makes sense to keep using the transformer model and instead use a more aggressive setting. Because the transformer model looks so much better than the old CNN model, especially in path tracing games using ray reconstruction where the biggest image quality improvements happened, I actually think DLSS performance mode is now very usable at 4K in path tracing games with that new ray reconstruction. Whereas previously I liked to stay at more like DLSS quality and the performance wasn't great. Now, we're seeing that at performance mode upscaling, the 4090 is hitting 72 FPS, which is 20% faster than the 60 FPS we're getting from the 5080. However, the 5080 is usable here. It is averaging 60 FPS. Although the 1% lows are lower than that, meaning that you're not always going to be at 60 FPS, it will go lower. Also pay attention to the latency figures. We're kind of in the mid 30 millisecond latency because we're about to boost the frame rate using frame generation, but please notice that the latency has not gotten better. This is why I don't like NVIDIA marketing this as performance, because this is how they claim the 5080 can beat a 4090, is through multi-frame generation. There's a ×4 frame generation mode available for the 5080, which generates 3 frames between every 2 rendered frames. The 4090 only has access to ×2, which the 5080 can also do, and if we match those, the 4090 is 20% faster, and that means it has a higher base frame rate, so you can see the latency numbers. The latency numbers are here and here. The 4090 is delivering lower latency and a higher frame rate. It's a better experience running that same model. The 5080 can get a higher output frame rate with the newer model. I'll pause it here for a second to discuss that though. But notice that when you do that, the latency increases even more. So there's a performance cost to doing that in terms of game responsiveness. And so it is nice to have the option, but you need a high enough base frame rate for it to be a good experience, and it's not the same thing as better performance. It's better motion fluidity on a high refresh rate display. Overall, I feel like the 4090 is a better 4K path tracing card than the 5080 because of getting that increased raw performance to have a better overall experience even after kicking on frame generation. Although everybody's, cutoffs for what they consider usable baseline frame rates for frame generation is going to be different depending on your tolerance for image quality artifacts, latency, things like that. And even game by game, it can vary. Now, I do think the 5080 is usable, but it's a little borderline at 4K path tracing. 1440p path tracing, both cards do a much better job, although still are too weak for a native 1440p with no upscaling. The 4090 is hitting 49 FPS, the 5080 is hitting 40. You could technically play this, but I don't think it makes a lot of sense. The 4090 is 23% faster though. I would definitely at least kick on quality level upscaling with the new transformer model. It looks great, especially with that update to ray reconstruction. Now the 4090 is hitting 88 FPS versus 73 on the 5080. It's a 21% advantage for the 4090. Both are very usable here though. And that means that our frame rates are good enough that we can probably kick on frame generation, although I did also test out the CNN model to see if there are any major differences. A few FPS different, but not a meaningfully different experience other than the worse image quality, so I would definitely use the transformer model. So then, when I tested out frame generation at 1440p, I used the quality transformer upscaling in order to get there. Once again, the 4090, I think, in the ×2 mode offers the better experience for sure. It's 21% faster. If we do ×2 versus ×4, the 5080 produces 49% more frames, but it has worse latency and potentially worse image quality because it's generating frames from a lower base frame rate, which also makes the quality of the generated frames lower because there's a larger difference between the two rendered frames from which to guess what's happening in between. That being said, I do think the 5080 is very usable here, and if you had a 240 Hz or more display, having the ability to increase the motion fluidity up to an average of 227 here is nice, although the 4090 with its ×2 mode is still hitting 152 for motion fluidity. So how transformative is that increase, especially with the latency penalties? The 4090 is still better there, but I thought the 5080 was pretty good for 1440p path tracing. At 1080p RT Overdrive, I'm just basically showing, I'm not going to do a lot of 1080p testing here, but I thought RT Overdrive is so demanding. Let's maybe see what happens. The 4090 is 23% faster at 79 versus 64. At least both of them can do 1080p path tracing without upscaling and break 60 FPS though. Now let's move on to another game. This is Indiana Jones and the Great Circle. This is a game that requires ray tracing. There's no way to turn it off. And this is its maximum settings that's not path tracing, not the full RT mode. 4K Supreme, both GPUs do amazing with no upscaling. 105 FPS versus 92. The 4090 is 14% faster, but they're both doing awesome. Until you kick on the full RT mode, and I just noticed a typo. This should say DLSS performance. So this is 4K full ray tracing with DLSS performance. Read it on my forehead here. You might not be able to see it. It says DLSS performance. Anyway, do you notice that I've got two images up for the 5080, and one of them is barely moving. It's moving at 3 frames per second. Let me pause here and explain what is going on in this test. This game has a texture cache setting, and at its maximum setting of Supreme, once you kick on full RT, which also uses more VRAM, the 16 gigabyte VRAM buffer on the 5080 spills over and performance tanks down to 3 FPS. Now, if you just adjust the texture cache setting down one notch to very ultra, which is still a huge texture cache, performance jumps back up to 55 FPS, and we get 65 versus 55 FPS. The 4090 is 18% faster. On the 4090, if I turn the texture cache setting down to very ultra, there's not really a performance difference. So this is still a good relative performance. It's just the fact that I'm pointing out that the 4090 doesn't need to notch down the texture cache because it has 24 gigabytes of VRAM and the 5080 does. Now, do I think that's really that big of a deal? Not really, because the texture cache here isn't saying that you're getting worse quality textures. The textures will still load in at the same full resolution. It's just that they can be more can be stored in cache, meaning they don't need to be swapped as frequently. So technically, the 4090 is probably going to have objects further in the distance running their full textures before, basically further out. Whereas the 5080, things further in the distance might need to come a little closer to the camera before it swaps in the full quality texture. Although I can tell you that in my actual visual testing, I can't see the difference because I think Very Ultra is still such a large texture cache that you are seeing the full res texture by the time you can actually tell a difference. So it's still inconvenient that the 5080 is having to worry about settings and the 4090 isn't, though. So that is worth mentioning as the only place in my testing today that I did see the 16 gigabytes of VRAM become a limit where the 4090 was not limited by that. Now, at 1440p full ray tracing, native resolution, we're once again seeing that they're a little bit weak for it without upscaling. 51 FPS versus 42, 21% faster on the 4090. But neither of them's breaking 60 FPS, so probably not the settings we're looking for. If we kick on DLSS quality, we're now at 75 versus 63, which is a 19% advantage for the 4090, and we have a good frame rate. You could then kick on frame generation from here, but I'm not going to do additional frame generation testing in this video. I kind of made my point about it in Cyberpunk. Just keep in mind that if you're at a good enough base frame rate, you could always kick on frame generation on both GPUs, and you have the ×4 mode available on the 5080. At 1440p, there we go, Supreme settings, not full RT, you'd be at 155 FPS versus 138, 12% faster on the 4090. So both of these GPUs can get an extremely high refresh rate experience at extremely high ray tracing settings if you don't want to turn on the full RT mode and tank your performance quite a bit. Now, Unreal Engine 5 showcase like Silent Hill 2, 4K epic settings with hardware ray tracing turned on. It's one of the few Unreal Engine 5 games on PC that allows the hardware ray tracing support. Neither GPU is delivering over 60 FPS, but the 4090 is 13% faster at 52 versus 46. I think you're just being stubborn at 4K on an NVIDIA GPU to not use at least DLSS quality, because you get a significant performance boost and the image quality still looks quite good. If we do that, the 4090 is now at 74, the 5080 is at 67, 10% lead for the 4090, and I think for this slow paced of a game, that's good enough. You could stop right here. It's a great experience. If we turn off hardware ray tracing and go back to native 4K resolution, the 4090 can hit 61 FPS, the 5080 is at 53, it's a 15% advantage to the 4090, but again, I think you're just kind of being stubborn if you don't kick on DLSS quality for the big performance boost you get out of it and still good looking image. We're now hitting 91 and 85 FPS respectively, 7% advantage to the 4090. UE5 kind of sucks, so it's possible we're hitting some system and or engine limitations, reducing the advantage for the 4090 here once we hit these higher frame rates. 4090 at 1440p epic settings with ray tracing on is hitting 83 FPS, which gives it an 8% advantage over the 5080, which is hitting 77. They're both giving a good experience, and here I don't think you necessarily need to use DLSS because that's pretty good frame rates, especially for this slow paced of a game. However, you could still kick on DLSS quality and boost to 108 versus 101, which is a 7% advantage to the 4090, and a very smooth experience now on both GPUs. If you go to epic settings without hardware ray tracing, you can get high frame rates without any upscaling at 101 versus 94 here, 7% advantage to the 4090. So this game didn't see as big advantages for the 4090, especially at 1440p resolution. Whether there's any system limitation involved there, that's a question. Final Fantasy 16 at 4K Ultra, the 4090 is showing a 25% advantage, and it's mid-60s versus low 50s on the 5080, 66 FPS versus 53. I think that is meaningful, but then again, at 4K, I would be kicking on DLSS quality. In fact, I did when I played this game on a 4090. And it was, now it's 93 FPS versus 81, 15% advantage for the 4090. And they're both getting a very good experience now. 1440p Ultra, we're getting 103 versus 92. 12% advantage for the 4090, and I don't think you need any upscaling here. It's a good frame rate for a single player title. God of War Ragnarok at 4K Ultra, I don't think you need any upscaling. 98 FPS versus 85. They're both doing great, but the 4090 is better by 15%. In kicking on DLSS quality, we get 136 versus 118, 15% better on the 4090. And if we go to Horizon Forbidden West, we get another game where native 4K runs great. 4K very high settings, which are the highest settings in the game. 27% lead for the 4090, but it's 95 or 75. They're both very, very playable. Although again, you can kick on DLSS quality and boost performance even more. 128 versus 112 now, the 4090's link shrinks to 14%. If we go to 1440p native resolution, max settings, 150 versus 130, 15% lead for the 4090, and I really don't think we need any upscaling in a single player game at this kind of performance. Hellblade 2 Senua's Saga at 4K high settings, we're getting 62 FPS on the 4090, which does put it 22% faster than the 51 FPS on the 5080. So over 60 FPS, and one is not. This is a very slow-paced game, though, so how much that bothers you, I don't know. And also, I'd probably just kick on DLSS quality. And now we're at 96 and 82, so very good experience on both GPUs, 17% lead for the 4090. 1440p high settings, we're getting great frame rates without any upscaling at 98 versus 84, 17% lead for the 4090. And we're getting another game, Ghost of Tsushima, 4K very high settings where I don't think you even need upscaling necessarily for a single player game, 92 FPS versus 76, 21% lead for the 4090. But if you do kick on DLSS quality, you get even higher, smoother experience, 136 versus 119 FPS, 14% lead for the 4090. At 1440p very high settings, which again are the maximum settings in the game, we don't need any upscaling. It's 149 versus 130, great for a single player title, 15% advantage for the 4090. Call of Duty Black Ops 6 is a multiplayer title, so I'm testing this one a little bit differently. I turned down the settings to basic because in competitive shooters, oftentimes you want low settings to declutter the scene as well as boost your frame rate for a competitive advantage. At these settings, but 4K native resolution, we're getting 149 FPS versus 130, which is a 15% lead for the 4090, and honestly, you should probably want to kick on some upscaling or something even to get even higher frame rates. At 1440p native resolution, but basic settings, we're getting very high frame rates, 278 versus 237. That's a 17% lead for the 4090. Sure, you could upscale here, but if you're not getting the kill at these frame rates, it's a skill issue. Now, at 1080p resolution, we're starting to run into some system limitations where the GPU is not fully utilized on either of them, but the 4090 is running into that limit more often. giving only an 8% advantage, but again, that is CPU limited, 327 versus 303 in terms of overall frame rate. So what do I think of this overall? Again, I've already kind of gone over the graphs, but the overall summary was, in all the testing, 4090 is 16% faster. But if we sort it, we can see that there's some of that looks a little more CPU limited, so limiting to 4K shows a 17% faster, same thing in ray tracing. But again, what does any of this mean? Like, should you buy a 4090 instead of a 5080? Well, I mean, it depends on what kind of price you can find. 4090 production hasn't, I don't think they've really been in production for a little bit, so buying them new, prices are out of control. Again, you can check out used markets like Jawa, see if they have 4090s in stock and what sort of prices they're holding for them. But if there's a large price difference, I will say that while the 4090 is noticeably faster, in a lot of situations, you're still getting a very good experience on the 5080. For example, one of the places where I think the 4090 is definitely better is trying to do 4K path tracing, because just that increase to raw performance is useful, because this is just so difficult to do. You're not hitting super high frame rates on the 5080, not hitting super high base frame rates on the 4090 either, but any little bit extra you get before kicking on frame generation really helps the responsiveness and the image quality of the frame generation. So even though the 5080 has that ×4 mode, which is nice to have, I still think for 4K path tracing, I prefer the experience on the 4090. That being said, doing 4K on a 5080 and just not using path tracing, like we saw in so many games, it does a great job, even without DLSS. Horizon Forbidden West, 4K very high. Getting 75 FPS without any upscaling, and even with quality upscaling, you're now over 100 FPS, and you could even go more aggressive on upscaling, especially, with the new transformer model. And again, then you could kick on frame generation and all of that. So the 5080 is still a very powerful 4K graphics card, but like I said, I think the 4090 is a little better for 4K path tracing. Now at 1440p path tracing, looking at like Cyberpunk, RT Overdrive, DLSS quality, again, I'd probably use the transformer model on that. 73 base FPS on the 5080, and hey, that's before even trying to go down to like DLSS balanced if you wanted just a little bit more performance. And the new transformer model does look pretty good. It's a little bit more acceptable to go down to those resolutions, and then kicking on the frame generation model, right? Where if you have a good enough base frame rate, which at 1440p I think the 5080 can do, now you're getting a really good experience. And if you have a super high refresh rate 1440p display, having that ×3, ×4 frame generation to fill out that motion fluidity, I think is nice to have. So in other words, I still like the raw performance on the 4090 better. And like we saw, there are the very rare but not non-existent situations where the extra VRAM on the 4090 is also nice. Where was that image, right? Where we had to turn down the texture cache slightly on the 5080. Was that a huge deal? No. Was it annoying to have to do that on a $1,000 brand new graphics card? Yes. Right? So in other words, the 4090 is definitely more performance and more VRAM, and I'd rather have that than the multi-frame gen. But I wouldn't pay a massive amount more for a 4090 than for a 5080. So you have to just compare. I don't know how the prices are going to play out on the used market with 4090s, on the used market with 5080s, on the new market with 5080s. It's just, they just launched. We don't know how it's going to play out. I would pay a little more for a 4090 than for a 5080, but I wouldn't pay just like a massive amount more for a 4090 than a 5080. Unless you're doing something else with your VRAM than playing games, productivity stuff, which I don't really test, there's a lot of things where the additional VRAM actually is a huge deal, even in AI models and things like that. But again, my wheelhouse is more gaming testing. So for gaming, I like the 4090 better. It's disappointing the 5080 didn't beat it. I'm slightly concerned whether or not a 6080 will beat it if we get another 15% uplift, if that becomes the new normal for 80 class GPU generations. But yeah, how much more should you pay for a 4090? It's hard to say, but not a massive amount more. If you want to go off of raw performance, we could say you could pay, 17% more, but you also get more VRAM, maybe pay 20% more. So if you have $1,000 times 1.2, in other words, if I could get a 4090 for $1,200 instead of a 5080 for $1,000, I'd do it. But would I start paying like $1,500 for a 4090 instead of grabbing the 5080 if I'm just using it for gaming? Honestly, probably not, because the 5080 is, like I said, going to deliver a pretty great experience in every game. Despite the disappointing generational uplift, it is still quite powerful. Anyway, I think that's where I've settled on all of this. And man, I really hope the 6000 series somehow finds a way to deliver better than a 15% generational uplift. Or we're going to see the 4090 beating a 6080. I hope all of you have an excellent day.